Hi dear students, so we have the last topic of our first chapter, that is the methods for the calculation of atomic weights and molecular weights. So in our last class you might have heard how to do the experimental calculation of equivalent weight, and before that you might have seen how to calculate the equivalent weight theoretically. Now we are going to see how to calculate the atomic weight experimentally as well as theoretically. So the basic fundamental formula here is the atomic weight is equal to equivalent weight into valency. This you might have seen in the definition of equivalent weight also. There we say equivalent weight is nothing but atomic weight divided by valency. So we can rewrite it as atomic weight is equal to equivalent weight into valency. Okay, this is the first method. Okay, now the next method that is very important, but it is not mentioned in the NCERT. Okay, so this was there in the entrance exams for previous test and all. So I am teaching you just because when you do the previous question paper you might be encountering these questions. Okay, so here the second method is called Dulong's and Petit's law. What it is called? Dulong and Petit's law. The major important thing with respect to this law is this is applicable only for solid things. That means it can be solid metal or solid non-metals. But except there are certain metals which are not solid, for that also this is applicable. That exception is beryllium, boron, silicon and carbon. Okay, so the main point to remember here is it is applicable mainly for solids except beryllium, boron, silicon and carbon. Now listen here, what is this method or what is this formula all about? It states that atomic mass into specific heat is approximately equal to 6.4. Here one important thing you should remember, here approximately it is equal to 6.4. So because of this reason I can say, if I rearrange this equation, for example atomic mass is equal to what? 6.4 by specific heat. Since approximation is there, we are getting also what type of atomic mass? It will be approximate atomic mass. So please remember, by applying Dulong's and Petit's law, the atomic mass what you are going to obtain is only approximate atomic mass. You won't get the actual or accurate atomic mass. Okay, very important. So here you need to ensure that the specific heat unit is calorie per gram multiplied by degree Celsius. This is very important with respect to this law. Okay, let's see some questions in Dulong's and Petit's law. Okay. Hi students, so I hope you could see the question here. So just I will read the question. Okay, the specific heat of a metal is 0.031 calorie per gram multiplied by degree Celsius and its equivalent weight is 103.6. Calculate the exact atomic weight of the metal. Very important. They are asking you the exact. But we know that whenever we are using specific heat is given, we know that we apply Dulong's and Petit's law and we will be getting only approximate atomic weight. Okay, then how we can calculate the exact atomic weight? That is why this question is very important. Let's see how we can do this. Okay, let's apply Dulong's and Petit's law. So we know that approximate atomic weight is equal to, or it is like this, 6.4 divided by specific heat, correct? Specific heat expressed in calorie per gram in multiplied by degree Celsius. So when you apply this will become 6.4 divided by what is the value given? 0.031. Okay, again I will say this is approximate value. So when you do this, what is the value you will get here? I can say you will get a value which is equal to 206.45. Okay, so we are getting the approximate atomic weight here, but is that the correct answer? They are asking you the exact atomic weight. Here is where we will apply the first formula we have learned. We know that atomic weight is equal to what? Equivalent weight into valency. So what is valency basically? So I can write valency is equal to, okay, or I can say this will be valency is equal to atomic weight by equivalent weight, correct? But here is where the problem, we don't know the atomic weight, exact atomic weight we don't know. So we will put here what actually? Approximate atomic weight. So this will become what actually? I can say approximate valency approximate valency is equal to approximate atomic weight, that is 206.45 divided by the equivalent weight. Equivalent weight is clearly given as 103.6. So I will write there 103.6. So this, if you do, you will get it as, you will get an approximate value as 1.99. Please remember, again this is approximate. It is approximate valency. Okay, approximate valency you are getting. Now tell me, you know that 1.99 is not at all a possible valency, correct? Because valency cannot be any fractional number. So we will round this to 2. Then it will become what actually? Exact valency. So this can be written as exact valency is equal to 2. Now we got the exact valency. Do you understood the logic? How we are changing from approximate to exact? Because valency cannot be a fractional number. So the nearby integer value is 2. Then that will be the exact valency of that particular metal or particular metal. Now we will calculate the actual atomic weight. Okay. So let's see how to calculate the actual atomic weight. Now tell me, the actual atomic weight will be what? Equivalent weight into valency. So I can rearrange this equation. You could see here. So I will rub this. Okay. So I can write here actual atomic weight is equal to actual atomic weight is equal to, tell me, equivalent weight into actual valency. Equivalent weight into actual valency or exact valency. Anything you can say. So actual atomic weight is equal to equivalent weight is same. It is not changing. So that is given as 103.6. But the actual valency is what? 2. So what will be the value when you multiply this? You can say you will get 207.2. So this is the exact or actual atomic weight of this particular metal. So I hope you understood where we are shifting from approximate to actual. It is the place where valency getting changed to actual valency. Then the corresponding atomic weight we will be obtaining is also actual atomic weight. Okay. So next we are going to discuss the third method for the determination of atomic weight. So that is called law of isomorphism. Okay. Regarding this law, this is not seen much in exams, but in some exams like KVPY or something, there we could see these questions. Okay, so there it will be useful for you. So I will tell the idea. This is very simple, just you should understand, that's it. So first of all, let me say, before going to law of isomorphism, I will tell what is isomorphic substances. I can say isomorphous or isomorphic substances are those crystals which have the same shape and size, and that can grow in saturated solutions of each other. Okay, I hope you didn't understand anything. Let's listen. Okay, consider these two crystals, zinc sulfate dot 7H2O, ZnSO4 7H2O, okay, and FeSO4 7H2O. Now you could see here, the only difference between these two here is, here zinc is there, here iron is there. So zinc is replaced by iron in this compound. Okay, so they are telling, so these two are isomorphous substances. Okay, there what it is doing, if I am replacing zinc here with iron, then it still can grow. Okay, and if I replace iron with zinc, still it can, okay, they will have the same shape and size and they will grow each other. So what is the conclusion here is, here the if you want to replace iron here with a zinc, what is mandatory? You know that zinc should have the same valency as that of the iron. That is the most important thing in the law of isomorphism. Whenever you say two substances are isomorphic substances, then the metal element present in that should have the same valency. Very, very important. Now if you read the statement, what is law of isomorphism? It states that mass of two elements, let it be zinc and iron, mass of two elements that combine with some mass of other elements. So here the other elements are this one. Okay, so I can say this one. So that combines with the same mass of other elements. Almost both are same mass of other elements in their respective compounds are in the ratio of their atomic masses. Okay, now if you see here, mass of one element, for example here the element A, let it be zinc, okay, that combines with a certain mass of other element. There will be some fixed mass for this much. I can say let it be X. Okay, then divided by mass of other element B, that is what actually iron, okay, that combines with the same mass. Then the same mass means this should also be what actually X. So that combines with the same mass of other element. If I take the ratio of these two, this will be in the ratio of their what actually atomic masses, that is atomic mass of A divided by atomic mass of B. So I hope you got a slight idea regarding this. Now we will see how they will ask question with respect to law of isomorphism. Okay. So very simple, isomorphous substances are those substances which have the same shape and size, and if they are kept in the solution they will grow into the same, or they can grow each other. Or that means if you have a solution where iron is replaced with the zinc, still it will have the same shape and size and it will grow each other. Okay. So it's very simple law of isomorphism. Let's see how the questions they will ask from this area. Okay. Hi students, let's see an application of law of isomorphism. Okay, so just read the question here. A metal M forms a sulfate which is isomorphous with magnesium sulfate 7H2O, MgSO4 7H2O. Full stop. If 0.6538 gram of the metal displaces 2.16 gram of silver from silver nitrate solution, then the atomic weight of the metal is. Okay, so here we need to apply two concepts, then only you will get the answer. First we need to apply the concept of equivalent weight to calculate what is the equivalent weight of the metal. So before we go into that, since the first statement states that the metal M is being isomorphous with the MgSO4 7H2O, that means what actually, what will be how the metal sulfate will be existing? I can write metal will be existing as, or metal sulfate will be existing as MsO4 7H2O. Now listen, why I am able to write like this? Because the first statement states that it is isomorphous. Isomorphous means this magnesium can be easily replaced by what? The metal M. Why? Because both are isomorphous. So both the metal as well as the magnesium should have the what? Same valency. I know that the valency of magnesium is what? 2. So the valency of the metal should also be what? 2. So the formula should be MsO4 7H2O. But from this, can you calculate the atomic weight of the metal? No. So how to do that? Let's see. So we know that equivalent weight of the metal is equal to, we have learned this, weight of the metal, correct, weight of the metal divided by weight of the silver, weight of the Ag into 108. This we have learned. Experimental method, experimental determination of equivalent weight. In that section we have learned this formula. So weight of the metal is how much? How much is the weight you have obtained? 0.6538, correct. And displacing how much amount of silver? 2.16 into 108. So from this I will get what will be the equivalent weight of the metal. So if I calculate this, I will get the equivalent weight of the metal as 32.69. 32.69. I got the equivalent weight. We know that from our first formula, what is atomic weight? Equivalent weight into valency. So I can write atomic weight of the metal is equal to atomic weight of the metal is equal to equivalent weight into valency. Correct? Atomic weight is equal to equivalent weight into valency. Equivalent weight we have calculated it. So that is coming around 32.69. And what is the valency of the metal? Just now I have told it is isomorphous. That means what is the valency of magnesium? That will be the same as the valency of the metal also. Magnesium, the valency is 2. So for the metal also the valency is 2. So I can substitute that 2 here. So what answer I will get if I do this? So I will get an answer 65.38. So I got the atomic weight of the metal. So right now you have seen how the law of isomorphism is used in the question, how it is applied. So you can expect questions of similar nature for JEE or in KVPY, but for NEET I am not expecting this, but you need to learn this, just an understanding, so that will help you to gain the confidence when you write different types of model exams. Okay. Hi students, let's see one more question from the concept of law of isomorphism. So I hope you could see the question. Just read the question. The carbonate of a metal is isomorphous with the magnesium carbonate MgCO3 and contains 6.091% of carbon. The atomic weight of the metal is nearly. So from the first statement I understood that there is a metal carbonate is there and that is being isomorphous with what? Magnesium carbonate. So let's write, so this is isomorphous with magnesium carbonate means both magnesium as well as the metal has the same valency, that is 2. Okay, so let's write the formula of the metal carbonate. So the formula of metal carbonate is equal to what? Tell me. It will be MCO3, correct? MCO3. Now what is the next thing you can calculate? We can calculate the molecular weight of this metal carbonate. What is the molecular weight of the metal carbonate? Molecular weight of the metal carbonate is equal to I know that I don't know the atomic weight of M, so I will write M plus carbon is how much? 12 plus 16 into 3, 48. So I can say it is M plus 60. Now many of you have wondering why I am calculating the molecular weight. I will tell. What they have given in the next statement, they are telling it contains approximately 6% of carbon. We know that percentage of an element in an organic compound. How we will calculate that? We know that percentage of carbon. Okay, so the percentage of carbon is equal to that atomic weight of the carbon, that is 12, divided by total molecular weight of the compound. We know that that is M plus 60, correct? M plus 60. And we know that what is the percentage of carbon given in the question? Approximately 6%. I can write 6. Okay, so now I can calculate this. So just cross multiply. So 12 is equal to, but here you need to ensure one thing. So since it is percentage, what should be done here? It should be multiplied by 100. That you should ensure. So multiplied by 100 so that this will become, you can write here 6. Or otherwise you should write here 6 by 100. Then 100 will come here. Both is correct. So just multiply here. This will become 1200. Cross multiplying 6m plus 360, correct? Now 6m is equal to 1200 minus 360. Now if you calculate this, this will become 6m is equal to 840 and m is equal to 840 by 6, that is equal to 140. So this I will get as the answer. So 6 for 140 I will get. So I hope you understood. Here we have applied the basic concept. Percentage of an element is equal to mass of that particular element divided by total atomic weight, total molecular mass of that compound multiplied by 100 will give you the percentage. This we have learned earlier. Same concept I have applied. Only thing here is formula of the metal carbonate. How I have derived it is MCO3 because it is isomorphous with the MgCO3. That is why I am able to write it is MCO3 and thereby I am able to write the molecular weight of the metal carbonate. If I am not able to write MCO3, it is not possible to write what? The molecular weight of the metal carbonate. Okay, that is the application of isomorphous, law of isomorphism. Okay, I hope you understood the concept. If you have not, please get back to us. Okay. So hi students, let's see the fourth method, that is called volatile chloride method. Okay. So this is the fourth method by which you will determine first the valency, then you will calculate the atomic weight. Let's see how it is. So there are required some conditions are there. So whenever you are doing this, the mandatory, this is an experimental method. That's why some conditions, preconditions are there. So one condition here is if you are taking that element and its chloride. That means element when combining with the chlorine, it will form elemental chloride. That elemental chloride should be in what state? It should be in vapor state. This is one mandatory condition. Why we are saying it should be in vapor state? Then we should know what actually its vapor density. That's why VD we say. So what is required to perform this experiment? One data you need is the vapor density of the chloride. That chloride's vapor density you should be having, and the next thing you should be having is the equivalent weight of the element. So many students will say, sir, if I know the equivalent weight, I can calculate the atomic weight, right? Yeah, how it is? Atomic weight is equal to equivalent weight into valency. Valency you need to find it out. That is where this method will help you. This method will help you to calculate the valency. How we are doing it? Let's see. We will say the valency of the element, let the valency of the element be X. Okay, if X is the valency of the element, then how we can write the formula of its chloride? We know the chlorine's valency is 1. That's why 1 will come here. 1 will come here, and the metal valency is X. That's why X is coming here. We will interchange and write, you know that. Okay, so the formula of its metal chloride is equal to what? MClX. Correct. Now how will you calculate the molecular weight? Molecular weight is equal to atomic weight of M plus X into atomic weight of chlorine, that is 35.5. So atomic weight of M plus X into 35.5. Now we know that atomic weight is what actually? Atomic weight of a metal is equal to equivalent weight into valency. Equivalent weight they have given, it is the given data required, so it's a given data. E into valency, we are assuming it as X, so E into X. So this value I can substitute in this equation, that is molecular weight. The equation I can say let it be 1 in equation 1. So what it will happen? Molecular weight is equal to Ex plus X into 35.5. Same thing. Then I know that molecular weight from our previous things we have learned. We know that 2 into vapor density, or vapor density is molecular mass divided by 2. So I can write molecular weight is equal to 2 times the vapor density. Vapor density is also a given data. So 2 times vapor density is equal to Ex plus X into 35.5. So I am taking X as common. So X into E plus 35.5. So from this, you know what is VD, vapor density given. You know the equivalent weight also. From this I can calculate X value, which is the valency. So X is equal to 2 times vapor density divided by equivalent weight plus 35.5. So once you get the valency, what you need to do? You just need to apply in my equation 2. Okay, in equation 2 if you apply it, X you know, equivalent weight you know, you will get what? Atomic weight. So this is also a rare method. Sometimes they used to ask in exams, very rare, but for JEE you need to learn. So please understand, nothing is there, a condition, an experimental condition where you know the vapor density of that particular metal chloride and you know the equivalent weight of the element. You need to calculate the atomic weight. To calculate the atomic weight, it is mandatory equivalent weight into valency. The valency can be calculated by 2 times the vapor density divided by E plus 35.5. Either you can remember the formula or you just know how it is being derived, so that it will stuck in your mind how to do that. Okay, so I hope you understood. So we will do one question based on this and then we will switch to the next method. Hi students, so let's see one of the applications of volatile chloride method. So I hope you could see the question here. Just read the question. The oxide of an element contains 67.67% of oxygen and the vapor density of its volatile chloride is 79. Calculate the atomic weight of the element. So we need 2 data to apply volatile chloride method. One is we should know the vapor density. Okay, that is given here. The next thing we should know is what? The equivalent weight of the element. That they have not given, but instead they have given a clue here. The oxide of an element contains 67.67% of oxygen. So from this I know that I need to apply oxide formation method to find out the equivalent weight. Then I should apply the volatile chloride method to calculate the valency. Then multiply the equivalent weight with valency, you will get the atomic weight of the element. So let's calculate the equivalent weight of the element. So equivalent weight of the element is equal to weight of the element divided by weight of the oxygen into 8. So this we have learned already, correct? You remember, I hope, oxide formation method. Now what is the weight of the element here? So we know that the oxide of an element contains 67.7% of oxygen. So the remaining will be what actually? Element. So what is the element's mass? 100 minus 67.67. So if you do that, you will get it as 32.33. Now what is the weight of the oxygen? We know 67.67, correct, multiplied by 8. So 32.33 divided by 67.67 into 8. 32.33, how you are getting? 100 minus 67.67, that is the weight of the element. They are directly telling the weight of the oxygen in that is how much? 67.67. So I am applying that. Okay. Now on calculating this, you will get the equivalent weight of the element. So the equivalent weight will come around as 3.82. Okay. Now we know the equivalent weight. What is the next thing you need to find out? The valency. So we know the valency X is equal to what? 2 times vapor density divided by E plus 35.5. How I got this formula? Just we have seen the derivation. Okay. So 2 times vapor density means 2 into, what is the vapor density given? 79 divided by, what is the equivalent weight we calculated? 3.82 plus 35.5. So this you calculate. When you calculate the X value, you will get an approximate valency. So I may say that valency will be around 4. So this value is 4. Now you know the valency. So this I will say it as valency. Okay. And this is the equivalent weight. Now tell me what is atomic weight. I can say atomic weight is equal to equivalent weight. Equivalent weight is 3.82 into valency, that is 4, and this will be the atomic weight. So how much it will come around? So this will be 15.28. Okay. So one more time I am explaining the concept. Very simple. They will give some clue to calculate the equivalent weight. Here they have given the oxide formation method. So from that find the equivalent weight of the element. Next they have given the vapor density directly. So vapor density is given, means you can apply volatile chloride method. X is equal to 2 times vapor density divided by E plus 35.5. Then you got the valency. Once you know the valency and equivalent weight, atomic weight is equal to equivalent weight into valency, you will get the answer. Very simple. Okay, I hope you understood the application. Next we will go to the next method. Okay. Hi students. So the last method for determination of atomic weight is called specific heat method. Okay. Here 2 things to be taken care. You should know Cp and Cv. What is Cp and Cv? This you are going to learn in physics. Cp means heat capacity at constant pressure and Cv means the heat capacity at constant volume. What is heat capacity? The amount or the capacity of a substance to hold the heat. That is called heat capacity. If I am able to hold 500 joules of heat myself, then I may say my heat capacity is so and so, 100 joules, like that. So if they give that ratio, that is the heat capacity at constant pressure to the heat capacity at constant volume is equal to gamma. This is a basic fundamental relation that you are learning in physics. And suppose they are giving you that value, from that we can identify that particular gas is whether monoatomic, diatomic or triatomic. Very simple, just to check the Cp by Cv value. If Cp by Cv, that is equal to gamma, is equal to 5 by 3. 5 by 3 means 1.66. Then I can say that gas is monoatomic. Monoatomic means it will exist as a single atom. And if gamma is equal to 7 by 5, that is equal to 1.4, we say the atomicity is equal to 2. And if gamma is equal to 4 by 3, that is equal to 1.33, we say the atomicity is equal to 3. So in exams they may give different clues to find out Cp and Cv. Then you need to divide Cp and Cv to get the gamma value. Once the gamma value is identified, check whether which atomicity it belongs to. So once you calculate the atomicity, it is very easy. Just apply our formula: atomic weight is equal to molecular weight divided by atomicity. This we have already learned. If you have doubt, I will just explain. We know that, for example, chlorine. So chlorine, we know that how it will exist, Cl2. So its molecular weight will be what? 35.5 into 2, correct? So molecular weight I know it's 70. So 70, if I want to calculate the atomic weight, what should I do? 70 divided by what actually? Atomicity. Atomicity of chlorine. We know that chlorine exists as Cl2. So its atomicity should be 2. So easily I will get 70 divided by 2. Again I will get the atomic weight as 35.5. So very simple, atomic weight is equal to molecular weight divided by atomicity. So molecular weight we know, to calculate the atomicity, please apply the specific heat method. Okay, so this is how the last method, fifth method. Now let's see one question belong to, or one question that comes from specific heat method. This is very important for NEET. Sometimes they used to ask this. I have seen in many previous NEET papers. Okay, so we will see from our last method one more problem. Okay, I hope you could see the problem here. Vapor density of a gas is given as 16. If the ratio of specific heat at constant pressure and specific heat at constant volume is given as 1.4, then find out its atomic weight. So this is the question. So there are two things. They have given the vapor density of the gas also. Okay, so we know that atomic weight is equal to molecular weight, correct? Molecular weight divided by atomicity. Now molecular weight, we know it can be written as 2 times vapor density, and this is atomicity, correct? Now how to find the atomicity here? They have given the Cp by Cv ratio, which is equal to gamma, that is given as 1.4. I know that this corresponds to a diatomic gas, correct? So that is atomicity is equal to how much? Atomicity is equal to 2, correct? So now I can substitute there 2 times vapor density, that is 16. So 2 into 16 divided by atomicity, which is equal to 2. So tell me what is the atomic weight of the element. So I will get the atomic weight of the element as 16. Understood? So this is how you need to apply this. Here molecular weight they have given as vapor density. We know that 2 times vapor density is the molecular weight. And atomicity they have given the clue like constant pressure and specific heat at constant pressure, specific heat at constant volume. The ratio is 1.4. 1.4 corresponds to what? Diatomic. So that is atomicity is equal to 2. So I hope you understood the concept. Now we see what are the methods for the calculation of molecular weight. That is, only 2 methods are there. No much problems. We will just see that. Okay. So dear students, coming to the last topic, that is the methods for the calculation of molecular weight. From the board itself you can see only 2 sentences are there. Okay, so what are the first method for determining the molecular weight? The first method is you should know the vapor density. Just multiply by 2, you will get the molecular weight. And the next method is, of course we are practicing it. What you need to do, you need to calculate the sum of the atomic weights of the given compound. This we have already doing it. For example, you know that calcium carbonate is the compound. So how to calculate the molecular weight of this compound? Take the atomic weight, that is atomic weight of calcium, correct, plus atomic weight of carbon, correct, plus 3 times the atomic weight of oxygen. So calcium we know 40, correct, and carbon we know it's 12, and 3 into 16. So this, if you calculate, this will come around 100, correct? So this is the fundamental method, we are following it. So with that I am winding up the chapter. Almost all topics are touched, almost all problems we have done. So again I will give you assignments and extra questions, and also we will do doubt clearance sessions, and I want students to learn this chapter completely and get back to me. So in the next class we will start our chapter basic concepts of organic chemistry. So that is a very fundamental chapter as well as a lengthy chapter. We need to learn that. Okay, then it becomes the foundation for the entire organic chemistry. So thank you for your patience as well as listening to the class. Please do well. Thank you.